So, this is COMSC 122, the first Python course, and we're down to lists. So let's start with that. Here's the chapter from the book, the live workbook, and I must say this is very important. I'm very happy to do this. Lists are the structure I use most in Python. They're wonderful. Now, when I did Fortran long ago, and for that matter C, I mostly use arrays as a handy way to handle data. Lists replace all that. So a list is just a sequence in square brackets of anything. You can have different, here's cheddar, Edam, and Gouda. So you run that defines something called cheeses, and you can print it. You can print the list. All right, if I can only spell print correctly. There we go. So you can print it, that's what it is. All right. Now, they don't have to be the same type. You can have spam 2.05 and then a list inside here. So that list has all these very different elements in it. Each element can be of a different type. So if you just print it, you'll see this is a text, this is floating point, integer, and that's a list inside a list. You can have a list of lists. So they're very handy. The empty list is just empty brackets. And the length function gives you the length of the list. So there are 3 things in the cheeses list. You can see them there. All right, and actually it might be interesting to do the length of the T-list, which is perhaps a little not obvious. The T-list has 4 elements, spam, 2, 5, and this list counts as 1 element at this level. All right, so an empty list is length 0, of course, and so if they have a state diagram, they like to make these things. I don't really see the point, but anyway, numbers is not defined. All right. Well, I ran this, and that should have defined whatever they need. Oh, I guess I didn't run this one. Okay, fair enough. All right. There we go. So now you'll get this diagram. Cheeses, it points to that list. Numbers points to that list. All right, anyway. All right. So lists are mutable. So you can refer to an element. Cheeses sub 0 is the first element, cheddar. And you can change it. You can set numbers sub 1 equal to 17. So numbers here is 42 and 123. But when I set numbers 1 to something else, I can replace that 1 element. Another reason why they're very useful. All right, there's an index. Here I referred to numbers sub 1. So if you're going to refer to it by the index number, then it has to go from 0 up to the length of the list. And if I try to go off the end of the list, I think it'll make an error. Like if I try to set numbers 3 equals 17, yeah, then it'll complain. List index out of range. All right. You can use any integer expression. If you try to read off the end, you get an index error. And if you have a negative value, it counts backwards from the end of the list, which is kind of cute. So numbers here is 42, 123. So this is numbers 0, numbers 1, and numbers minus 1 would take you back to 42. Let's try that. Yep. Well, it didn't set it. Oh, it set numbers minus 1. I see, from the end of the list. I guess from the end minus 1 puts you here. I thought it would put you there. Okay, fair enough. Minus 1 means the last element of the list. All right. All right, so you can use the in operator, which is extremely useful. Is Edam in cheeses? It is true. Is this in cheeses, Wesleydale? It's not. So that's handy. And so now you can define a list here like we did before and have the length of the T. We talked about that. And 10 is not considered to be an element because the element is the list 1020. 10 is not in T. However, this is 0, 1, 2, 3. It is in T sub 3. T sub 3 is a list. And it's in there. All right. So I hope that's clear. And there are slices. Like what I just did, you can refer to one element of a list with just a number here, or you can refer to a range of elements, which is from the first number up to but not including the last number. So here I have the elements 0, 1, 2, and 3. So 1 to 3 means I start at 1 and continue to 2, but don't include 3. So it should be BC. And so it is, B and C. If you don't put in the first index, it starts in the beginning. And this should look familiar. This is just all the same rules that we had with strings. And if you omit both of them, you get the whole list. And if you omit the second one, the list goes to the end from 2 to the end. All right. Now, here's something that has driven me nuts many, many times. And I've probably demonstrated it before, but I'm going to demonstrate it again. So there's letters. And if I have letters 2 equals letters, okay. And now, enter I say, okay. Now I set letters sub 0 equals X. And then I print letters, and then I print letters too. I've done this a million times, and in Python, or I mean in Fortran or C, when you do this, you get a second copy of the list. And then when you change the first one, it doesn't change the second one. So this is a reflex for me. I've been doing this for 40, 50 years, and it doesn't work in Python. In Python, when you do this, you create a second pointer to the same list. It's just a second name, like an alias for the same list. So when I change letters, it's also changing letters too. So they're both X, B, C, D. And this has got me so many times. If you actually want to make an independent list that's a copy of the first one, you have to put .copy here. Now you're going to get a copy of the first list. So now they're separate. Now the first one you change to X, it doesn't change the second one. So it took me many struggling, frustrating times to learn this. You have to use copy in Python to get an actual second copy of something. All right. You can combine lists together. Another way you can do it, you can do it with copy. This is one way to make a copy. Here's another way to make a copy with the list function, list of letters. The plus operation will combine lists. So 1, 2, and 3, 4, adding them together, you get one list with 1, 2, 3, 4. That's interesting. I thought another possibility might be you would get the first element being 1, 2, and the next element being 3, 4. But that's not what happens when you add them. It combines them in this fashion. I've never done that, and certainly I would be reluctant to do it and not entirely clear what the result was going to be. You can multiply something by 4. You'll just get 4 elements of spam, 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 spam. But you can't do other mathematical operations. There is something called sum that will add up the elements. All right, and I wonder what T1 is. I've forgotten. Let's print it. I can see what it is. Okay, it's 1 and 2, so, I see, it's up there. So adding up the numbers, you get 3, and you can have minimum and maximum. All right. And you can append. This I use a lot. Append adds an element to the end of the list. So I have letters. Let's print letters first so I know what's going on. All right, so I'll print it and then add an E to the end. And so you see it's BCD, then you add an E to the end with append. All right, extend will take a list as an argument and append all the elements. So this is how I would put an F and a G on the end. All right. And you can remove elements from a list. You can do it with pop. Pop will remove the element at that index. So this is A, B, and C, and popping 1 will remove the B. And so the return element of pop is the thing you removed, and the list is what's left over. All right. You can also do it by labeling the letter. So here I'm going to remove the actual element called B, and the return element is none. But when I look at the list, I'll see it's gone. Now, one thing I wondered about here, and I'm glad to have a nice chance to do it, what if you have 2 B's in here? All right. Now, if you remove a B, what's left? And it only removes the first B. That's interesting. And I wouldn't be surprised if there's some optional parameter to remove all the B's or a different function. But I wondered what it would do. It just removes the first one. Okay. All right, if the element you ask for is not in the list, there's a value error. So if I try to remove a D, then it gives me a value error. All right. All right, and so the lists are very much like strings. Lists and strings are the most common data types I use in Python, I think. So here's a string, 4 letters, and you can make a list out of it, and that's just going to put the letters in separate elements in a list. So you might do this if you want to process the letters one by one. All right. breaks it up into individual letters. You can also split it according to a separator. So here I have a string with 4 words, and if I split, it'll break it on normal white space, like spaces. You can also specify the delimiter. So here I could split it by dashes. So it'll take X parrot and split that into X and parrot. So you can split a string with any delimiter you want. And if you have a list of strings, you can join them back together with join. So after I have pining for the fjords, I could now do delimiter join the list, and delimiter is a space, so that will put them back together, putting spaces between them. Now, if the delimiter was empty, then of course I'd just get them all ramming together like this. All right. I'll put it back to the normal in case it's used later, but I don't think it is. And then you can use looping through list. I love to use for loops on lists. I do this all the time. So for cheese in cheeses, that will just go through every element of the list. It's a very nice way to go through a list of whatever you're trying to process. And you can split it. So I have my string, I split it, and then I go and print the words. And this S split is now a list, so I get all the words separated out. A for loop over an empty list, it's never true. There are no X's in this, so it won't execute this command even once. That's true generally. If you have an if statement that's false, then whatever's supposed to happen, if it's true, never happens even once. All right, and there's something called sorted that sorts the element of a list. So I have a scramble list here, and then the sorted of scramble is there. Now, remember, it didn't actually change the list. If I print scramble, after running it through sorted, it's still scrambled. It doesn't change the list into sorting it. It creates a new list that is sorted. And you could save it in another variable if you want to, like scramble2. And then you could print scramble2. There. And got to get rid of that extra character. All right. All right, so there's the original scramble, there's the sorted scramble. They're separate objects. Okay. All right, it works with any kind of sequence. So you can sort the letters in a string like this. The result is a list with all the letters in alphabetical order. You convert it to a string with join. But if you do, they're now alphabetically ordered. They're not ordered the way they were originally. All right, and you can put, this is with nothing, so there's no delimiter between them. All right, looking for comments. There aren't any. So here's a couple of objects. These are 2 strings. A and B are both strings, but they both have the same value, but they do not point to the same string. They're not 2 pointers that point to the same string. And there's 2 possible states. There's a figure here showing you this. All right. One possibility is that they're just 2 separate strings that happen to have the same value, which is what we've done here. The other possibility is they're 2 pointers to the same data storage. All right. And you can find out if they are the same by seeing if A is B. And it's true. Wow. I didn't expect this. I expected this to create 2 separate strings. This is another trick like the one I mentioned earlier with lists. That's pretty bad. Wow. So when you set 2 strings to the same literal value, Python will just make one storage a literal value and point to it. That's pretty rude. But anyway, that's a good thing to know. I've never run into that. If so, it would have surprised me. I was quite sure it would do this, but that's what the older languages I know, like BASIC and Fortran and C, would do. Python likes to do this, which is very confusing to me, but I'm learning to get used to it. All right, so now here I'm going to create 2 lists, and let's see if A is B, and it's false. So that is really confusing. Wow, this is really rude. I don't know why these would have contradictory results, where these point to the same string and these don't point to the same list. That's rude. However, I do appreciate learning this way to test it. That's how you can tell what's going on. That's that I can remember. Remembering when it's going to happen and when it's not going to happen, I'm not going to remember that, but I am going to remember how to test and find out. All right, so there's the state diagram here. So A and B well, this is wrong. Oh, no, that's right, the lists. The lists are two separate lists, but the strings are not two separate strings. How rude. All right. Then there's aliasing. Yeah, this is the one I was talking about. If you make one string and then you set B equal to A, then B is A, so what you have is another label for the same list. You don't have a copy of the list. So that state diagram is going to be here. A and B are both labels that point to the same data. That one I know from hard experience. All right. And so if you change B sub 0 to 5 and then print A, it's going to have changed A because they're both using the same data storage. All right. For immutable objects, alias is not that much of a problem. I was thinking about that. Here it doesn't really matter because you can't change the banana anyway. So in that case, it doesn't really matter since they're immutable objects, whether you have one copy or two copies of it. Yeah, this is a reassuring point. All right. So when you pass a list to a function, the function gets a reference to the list. So if the function modifies the list, the caller sees the change. So that's interesting. You can have pop first lists and return list pop 0. And this is going to remove the zeros from the list. It's going to return the zeros that were popped off, the element 0 that was popped off, but it's also going to modify the list by popping off the 0th element. So it will modify the return value, will return values from the function, and the argument will be modified. So I have A, B, and C, but after popping it, A is going to come out, and what's left is going to be just B and C. So that's an interesting fact. If you pass in a reference to an object, then the function is still manipulating the other object. All right. Whereas if you just pass in a value, like an integer value, then it makes a copy of the value and processes the value in the function. It doesn't change the calling function's parameter. All right. So here we're going to make a list. Okay. Oh, I see. This is making a diagram, I think. Okay, that's why it's hard to read. That's just there we are. So I'm going to have main. In main routine, letters goes here to here. In pop first, right, the list is going to pop the first one. Okay, that's just explaining what we did up above. All right. So we can make a word list. We're going to download some list of words here. And then we're going to read every line and append them to a word list. So we'll see what it looks like. We're going to have 113,000 words in this word list. That's a lot of words. So we're going to read them and put them in a string and then do the length of the string, which is 1 million words. A different number, more than 1 million characters. Well, how can there be 113,000 words and 1 million characters? Okay, so it's something like 10 letters per word. That makes some sense. Okay, good. There are more letters than there were words. That's what I wanted to see. So now I have more than 1 million characters. We can now split it up. I want to see what's going on here. I'm going to print string. Let's go up to, say, the 20th character. Colon 20. There, so I don't want to print 100,000 or 1 million or whatever, but I would like to get some idea what it looks like. Okay, so it's put every word on a separate line. The carriage returns are in there. Okay, that's interesting. And, all right, now I'm going to split it. All right, and so now I have 113,000 words. All right, now to check if a string appears in the list, we can use in, so is demotic in there? And the answer is true, but contrafibularities is not in there. Okay, there you are. All right. All right, and I think that's it. Let's see what debugging is important. Most list methods modify the argument and return none. So if I strip something, it doesn't return any value. So here's a word. I'm going to strip it by removing the exclamation point, and then it returns that word that's stripped, and there it is. All right. But if you write code like this, a list, and then you remove 3, then what's returned, the return value is not, the return value is not the list minus 1. In fact, let's see what the return value is. It's no return value. It's none. So that's interesting. You can't, it doesn't return anything. It modifies the list, though. So you would do a T remove, but you wouldn't do a T equals T remove. This would be the way to accomplish this, where you're going to remove the third item and have the list with the third item removed. That's what you do. All right. All right, and that's it. The summary of lists, they're extremely useful, and there's a lot of hands-on projects to do with them. So let me stop this.